good to kind of prove the other side. And the
Yeah,
truth is always somewhere in the middle, right?
exactly. Hindsight is your best friend when you're posturing on Twitter. That's for sure.
Yeah, well said. Yeah,
Uh,
so what do we see here?
okay, so a couple things. Revenue just over 57 billion, mostly from data centers, and that's up 62%. Uh,
That's so wild. Up
look at this chart.
62%.
Yeah. And then operating income 36 billion, up 65%. Net income 32 billion, again up 65%. Net income being after taxes and interest. Um,
Gaming up.
Gaming's up.
That's
Fantastic.
it feels like that's their like side project at this point. I mean, look, I actually know they're pretty sensitive about saying that, but it's like obviously AI is the thing and to see that gaming is also up. I mean, I'm a gamer. I love to see it.
Yeah, you and Jonah might be pushing the stock up on your own here.
Yeah, that's right.
What are you playing these days, by the way?
I'm
Any of the new
I'm
games?
playing what everybody else is playing, Arc Raiders. That's
Right.
I haven't had much time in the game, but I've been playing that. I also went back to Path of Exile 2, which is, I just love that category of games. I loved all the Diablo games. I just it's easy to play. So yeah, I've been playing a lot of that as well.
Were you a bit of a hater when Arc Raiders first came out and then you converted? Am I
I don't know
remembering
why
that
you
right?
had to bring that up on the show.
Yeah, I thought
But
that
yeah,
may have
a
been right.
little bit. I didn't understand it. I actually asked for a refund and then I kept watching everybody playing and I was like, okay, let me give this another try. And then I kind of understood it. There's a social element.
Hmm.
It's like very tense when you're actually playing the show and yeah.
What am I missing here? A little FOMO. All right, and then most impressively here is actually gross margin, 73.4%. This is well above industry average. That's a very healthy gross margin.
Yeah. It
Um,
looks like Nick, maybe our stream froze. Give us 1 minute as we work out that technical issue.
okay,
Okay, we have to restart. Give us 1 second, everyone. Okay, we're
okay.
good to go. Keep going.
Think we're
Sorry,
good.
buddy.
Yeah, yeah. Last point here. They're forecasting next quarter to be even bigger. So demand seems to be consistent, surprisingly consistent, and all of these hyperscalers are locking in their Blackwell chips. And then you also have, and I mentioned this earlier, but the cloud GPUs, like they're hard to get. You can't
Yeah.
rent them out anymore.
Yeah.
So
Demand is there. I mean,
demand is there.
and it continues to grow. And if you're betting against artificial intelligence as a technology, as an innovation to change the world, you're making the wrong bet. If you're betting in the short term that there's over investment, capex wise, like okay, I can like at least understand that, but to bet against AI just seems absolutely bonkers.
That is great foreshadowing for talking about Michael Burry, which hopefully we'll get to in between guests. But Alex, are we ready to bring on our first guest?
Yeah, let's do it.
Okay. Well, let me introduce him real quick. This is going to be a very fun conversation. So, up first, we have Himanshu Tyagi, co-founder of Sentient, a company building open source AGI. They are backed by $85 million from the Peter Thiel Founders Fund. Himanshu, welcome to the show.
You guys, nice to be here.
How
Yeah,
did I do
welcome,
on the
welcome.
pronunciation, by the way?
Not bad, not bad.
Not
It's
bad.
actually, yeah, it's simpler than it looks. That the thing with my name is that if you don't over try, you'll be fine.
Okay. Trying
All
too
right.
hard. I get it.
Yeah.
Um,
Nick is known for that.
I'm known for that. All right. So just starting out, give us a quick overview of what Sentient is and why you started the company.
Yeah, Sentient is building open source AGI. The idea is that from day one we have been thinking how to keep this whole AGI open source, how to get all these different kind of reasonings in open source so that AGI can come out of it. And this includes various aspects of sustaining open source, not only getting innovations in open source, but also getting people to contribute their best products, best agent in open source. Since we started, something drastic has happened. China has come out as the champion of open source, which is nobody expected, and that puts us all on a very different trajectory. But largely, China has been focusing on models, and there's more to AGI than models, and there's much more to AGI than models and just the models. So we have been getting all the builders contribute their best reasoning agents in open source.
Himanshu, can you start with what your personal definition of AGI or your company's definition of AGI is?
Okay, that's a great question. My definition is something I borrow from John McCarthy, which is the most general AI possible, which is an AI which can understand common sense, can self-improve, and can be at human level. There cannot be a single bar for AGI. I think AGI must be pursued. I don't believe that here is AGI and it's there. I think it pursues and it keeps on going up. And we understand how humans do different tasks and how well they are. And we will try to catch up with humans in all different tasks. So it is a
And,
vague definition.
mhm. So sorry to interrupt. So it is not like a light switch. It is not something that suddenly happens. It is a gradient that happens over time. But if that's the case, like how do you know when it's here?
Hopefully, it will never be here, and we are always looking for more. I don't think it is like 0, 1. And you know, I mean, I can talk at length about it. This is the sort of the reason for us to exist. That AGI is basically getting more and more sophisticated reasoning to AI. AI is, I don't want to call it a parrot, but these models are sophisticated parrots. Many humans are sophisticated parrots, and they repeat it. So they repeat very sophisticated reasoning flows. They're not reasoning ground up. And AGI is generalizing this to more and more. So it is on things outside these models, hopefully humans, to get this new reasoning ideas, which then the models can take up and grow. So AGI will be pursued throughout. Maybe at some point we master coding, then we go to chemistry. When we master chemistry, we go to physics. Maybe some of this happens at all times. But at the end of the day, uh, there will be a lot more to be done.
Are there
And
certain fields that you expect to reach that moment first? You know, you gave the example of some scientific fields. Is there a rationale behind that?
I think the field which get there first, we all know what that field is. That is not a scientific field, that's engineering. The digital experience over the internet gets there first. Uh, our entire digital life will be first AGI-fied, if I may say so, that where we don't have to click all the things that you do over the internet. That I think will be the first version of AGI that we are already encountering. Right now, we have this sophisticated review and research machines like ChatGPT, which can do very deep literature survey for us and all those kind of things. But even our buying experience, our planning experience online, that goes to what I call AGI of the digital world first, and we are very close to it. Maybe 2 years, right? The whole internet gets rewired in a way that we are just expressing our intent and things are getting done and we are getting the output that we want. That's the first thing I feel will happen.
and okay, so you mentioned AGI as more than models. What are the different elements of the architecture of AGI?
Right. I think I personally like to define AGI as something anchored around reasoning. And I have a great definition of reasoning, which which keeps you asking for more. Reasoning is that part of AI which is out of distribution from a model.
Yeah.
So whatever a model can do, what it has not learned from its data, whatever is outside it, is what you have to reason through. So if you could see everything, the whole piece, all possible versions of the problem, and then solve it, then it's not reasoning. These models are nothing but they're just sampling some things. So whenever that answer does not exist in their distribution, they have not seen something like this or close to it before, the distribution that they've learned, then you have to reason through. So if I give you a lot of text, huge amount of text, much bigger than the context of the model, and then ask something about it, you have to reason to decide what do you pick up first and what do you do next on it. Now, answering these reasoning questions around models require many more things. It requires you to have this so-called agentic systems, and which we have been seeing around. But it can require you to have world models, for example, where you can evaluate which of these answers to choose, which makes sense. And we are thinking of these world models around robotics. But last 2 weeks, I've been seeing that a lot of people, because Jan LeCun announced a startup, and not announced, but it's expected, and A lot of people have been talking about Jan LeCun's stand and where his ideas are coming from, at least in some circles, at least among the people I follow. And you would see that world models are being talked about in a broader context in robotics, which is to say that we need this, there's more to reasoning than just an LLM. There are this mental model one keeps where you try your solution and then you plan what's the right way to do. So that is a part of the reasoning stack. How you improve the prompts automatically? How do you self-play like AlphaGo used to play in games and improve your
Mhm.
prompt automatically? That's a part of reasoning. And all this is happening. It's not that it will happen in the future. But the canvas is very vast, and there will be many domain specific arenas, domain specific world models which will be coming in.
And you also mentioned continuous learning is a big part of AGI and the continual improvement of AI. And Dwarkesh Patel a couple months ago put out kind of that thought piece where he basically pointed out, hey, once the models are baked, they're frozen in time, they're not actually continuously dynamically learning and updating their weights. Do you think that's a big missing piece?
You can update the model, but one other thing which I'm very excited about and which is something fascinating is you can update the prompts continuously, specifically for agents which are more strategic. Something like a sales agent is a very strategic agent. Uh, their strategy lies in their prompt, not necessarily in the model itself. And updating that prompt requires similar kind of algorithms what you use to use RL for updating the model weights. So even outside the model weights, this helps. But absolutely, there have been a lot of thoughts about how the model weights can be continuously updated. Uh, Typically, I'm not a big fan of using post training, RL based post training. I know that there have been breakthroughs in this kind of RL based pre training, but for post training, I guess you need a lot of large amount of data to do it. So I'm more on the prompt optimization camp. But this continuous learning will be a big part of AI. In fact, everybody knows that putting up an agent is now a child's play, but improving an agent is not a child's play.
Hmm.
And that's where this whole machinery comes in.
All right, so
So
I
let's, oh,
go
go
ahead.
ahead, Matt.
Uh, I have a broad question for you. Why open source? Why is that important to you? Why is that important to the world?
And maybe to add on to that question, talk to us a little bit about the landscape of open source, like open weights versus open model, and even like sovereign open source. Where you sit in that picture as well.
Yeah, so there are various motivations for open source, uh, multiple actually. So first and foremost is this whole idea that open source is how compounding happens of ideas, right? This is how research has been. This is what machine learning and AI itself stands on. Everything was open source. That's why you could do it. If internet data was not open source, you will not have any common crawl data, and you will not have any. Although even the data which was not open source was used, but that's fine, you will not have what we are looking at to begin with. This is how the compounding of knowledge happens. Particularly in the case of reasoning, as I'm pointing out, many of these things are sort of things humans have not articulated in the past. And when you bring them out, they better be in open source so that you can compound across. This is completely new human knowledge. It better be in open source. Nobody has ever expressed how they came up with their best ideas. They have come up with it. Maybe some people write about it, but it's very hard to express how you came about it. As this knowledge comes out, I think it needs to be in open source because it's humanity's knowledge and it must be shared. This is one important part. This compounding of ideas and even improvement only happens in open source. And this part, nobody will push back on. I think people are okay with this. The second part about why open source is the economic part. The way whole AI is pushing the economy is that now it is possible for an individual to set up a giant company, a one-person company. We have been talking about this one-person companies, and the whole notion of open source contribution has changed now. In the past, open source was some kind of an activist movement, and people were quite passionate about it. But now you see it's more of a also a CV building activity in the worst way. Like, hey, this is look what I've done, and some prestige and all that. But it is also how people would like to set up their businesses. This is how they want to get distributions, especially one person company. This open source matters a lot, and this opens a very different business model. People will come to open source to make money. People have in this cycle already. Last part is what you mentioned about the sovereign AI part, which is a very fascinating part. You guys, I was in the US for 10 years. I understand how US is fascinating and how it is frontier of innovation. But there's the rest of the world, and which is very interesting too. So one thing about the sovereign AI piece is AI is such a big socio-technical thing. It's bigger than technical, right? It is going to disrupt jobs at large, and it's going to be used for decision making at country level. So this sovereign AI has to sit on open source. And this sovereign AI is very interesting. In fact, I would say to your point about is open weights open source or do you want open data?
Yeah.
In the context of sovereign AI, open weights is not open source enough.
Mm.
Uh, Many countries, let's say the leading contenders of next AI, right? Like say US, China are the leaders. Who are the next players? And you would see France, Canada, India, uh, Korea, Japan is a bit behind. These countries are there. Now, all of them, most of them, are not going to treat Chinese open source models, open weights models as open source to build their sovereign AI. In fact, many of the institutions in these countries we are doing business with do not want those models to be deployed. They can prototype with them, they can develop their thing with them, but they cannot deploy because they don't know how the regulatory landscape will go. So they're looking for open source, which is completely neutral, not aligned with any country, has no backdoors hidden in it, which is the open source, which is very hard problem to actually nail down. Which is the at the very least what you can do there is all the training data is available for auditing. It's not easy to still audit. This is humongous amount of data, but at least it's available and there's a chance of auditability so that we know that this is the data we used and there are no hidden backdoors. So that's the sovereign AI's open source notion is very different.
And when I think about open source, I think decentralization is tightly coupled usually with it, but it seems like in artificial intelligence specifically, decentralization and open source might be butting heads because when you take these models, if you're taking a frontier model, they are massive. It's not something you could just run on a consumer grade computer. So like how do you think about decentralization and artificial intelligence?
I think there are different parts of it which cannot be decentralized. Yeah, maybe it cannot be on a computer grade thing, but so, so so for example, inference is not something that requires that many GPUs all the time, right? Uh, Two H200s, one Blackwell, whatever you like, it's fine. That kind of compute can do for a decent experience. This is more about experience. You can actually run it on your laptop if you like a decent model. Maybe not a very large model. Maybe a 120B model is possible in a smaller cluster. That's fine. It's just that the experience will not be top notch. So consumers, the most spoiled of the AI users, will not be satisfied for less compute. But for other use cases, this compute bottleneck inference time is not necessarily very high, although one can expect in near future workflows which last for a month. We're just doing solving some problem for a month with some checks and balances in the middle. Obviously, we are already seeing these 5 hour, 6 hour workflows of test time inferences. So a month is not far where you're solving some hard problems and just observing in the middle and guiding in the middle. But the other side, which people think is even harder to decentralize, is the training time thing. And as I said, this training cycles, when will they happen? When you improve the model further, when you take a new reasoning flow, train the model on this new complete reasoning flow. In that, earlier, I worked a lot on federated learning. In my past life, I have been an academic. I'm a professor at a university. And I used to believe that this federated learning and then decentralized learning will not be a real thing. But I missed a crucial point that you don't have to decentralize all the way. And what you can decentralize to is clusters, maybe not too small clusters, but you know, there are these pods of 500 GPUs. They're not that hard to get. Many people can put it up. It's like a good real estate project to buy this pod and put it up. It is possible to decentralize across those clusters. In fact, Google and all internally, they decentralize that way. So that kind of decentralization is possible. So what makes this hard is the overall regulatory and sort of tariff framework around chip distribution itself. I don't think that decentralization that way is a complete bottleneck. It is possible. People can host small clouds which can support, let's say, 500 to 1,000 GPUs of top size, and you can decentralize across them.
But who's actually doing that? Like when I think about decentralization, I'm thinking about myself as a consumer. How do I get my own AI? Maybe I'm running it locally. Maybe I'm getting it
Uh,
from a decentralized network. But ultimately, like who is going to have these smaller clusters of GPUs? Because we're not talking about a few $100s here. We're still talking about quite a bit of money, and then you're also kind of pitting that
Yeah.
against the larger, multi-billion up to trillion-dollar investments that these large companies are making.
Yeah, so the economics don't make sense right now, mainly because of because of tariff landscape. Mostly because of that, by the way. This economies would have made sense. It is much cheaper to run it, and if you run it globally, because you can have local power sources. People have made case that you don't need power backup everywhere. You can have redundancy instead of power backup, uh, and generator sets are actually a critical part of the cost in this. So there are ways to work out, except that these economies are not so open. You cannot sit in the US and trade in India. There are regulatory things around it. Who runs it? It's a $20 million investment. You could have given some returns from it if global markets were open. In the current space, I don't think this global market is open. In the current space, it is actually the sovereign AI builders who are the main buyers of this. So, for example, countries both Korea, India. I know for these two countries for sure, they only allow local clouds when they're building their local models, and it is to bootstrap that ecosystem, and it's coming in that manner. But if the global market opens up, there's an interesting play in this whole thing. I think eventually it will open up.
You mentioned earlier some surprise that China went the open source route, and there seems to be this general notion that you go open source to catch up, and then once you've caught up, you close it down. And I'm curious, as you think about that, like, first of all, do you think that holds up? Is that true? And then why is there surprise that China went the open source route? Did you expect something different?
I actually had not guessed that this will happen in this manner, although already there were very powerful Chinese models. Alibaba was already putting out these models. The reason I did not expect it is because this play will be about capturing distribution. And I did not imagine that China will have this kind of a marketing machinery, which US is well known for, to capture a global distribution.
Yeah.
And
Yeah.
you see the videos coming out of Chinese founders now. I can't. I had no clue. I was in the university system for a long time, and I hadn't seen this kind of enabled Chinese founders in my life. I think this is a new generation of very different Chinese who appeal to the global sentiment. Right? It's very interesting. I think the talent depth is very good. Also the entrepreneurship skill are very very strong, and it's very interesting. The whole generation is very interesting. And I would say China has one advantage that many of the big players like DeepSeek are not necessarily selling to the world. They want the reputation of the world to sell in China. Actually, they're after a domestic market, which is pretty decent. And this puts them at an ease. And it's a very fascinating GTM around open source. I had not foreseen it.
The marketing piece of that is very interesting. That's not necessarily something that I'd heard before, but you can have a brilliant model that performs well on all the benchmarks. It's very possible no one will know about it. You really have to lean into distribution and make sure that people are aware that that thing exists. And they've done a good job of that.
Yeah, and
Look at Manus.
Yeah, exactly.
Right. Do you and when you think back to DeepSeek, which seems like a lifetime ago, but it was earlier this year, do you think like that was the starting point of it all? Do you think DeepSeek was just this unique company that decided to go open source? Maybe the founder was just obviously very bought into open source, and then all like the Chinese government and all the other companies were like, oh, look at that, look how big of an impact this thing had worldwide. We need to follow suit. Or was it more strategic than that?
No, it was discovered, I think. I think nobody I would I don't know. I'm not so deeply coupled within the Chinese ecosystem. I don't think anybody was waiting for this to happen. It was a complete surprise. And the ripple effect across the globe was very interesting. I like many countries, again, India, because I'm from India and I spend a lot of time there. So India, for example, was still debating build models or not, and can we build models from the government and the policy side. And this DeepSeek movement was like, oh wow, and nobody is questioning how much money they spent and all that, right? Like they put out something. I think there's a piece of positioning, excellent. Uh, but suddenly, these everybody woke up and they're like, firstly, you can do this very efficiently. And secondly, it's an open, so why can't open gives you this confidence that I can also do it. Because if you can play around with something, you feel I can create it. And closed is like you don't know. Like nobody knows. Like Palantir, can you create a Palantir? Nobody will feel very confident. It looks like a crazy company which knows everybody's movement all the time. Nobody knows what it is. And I mean, you know some tools from them. But the global picture is like that. But can you create a deep sea? Everybody will believe so. You can see the weights. Why not? And that's, I think, a very different view. I feel it enabled a lot of people. And then the Chinese government and everybody backed it up. Obviously, now the ground level traction for DeepSeek is very high. All the local Chinese apps use it, and many schools use it, and government supports it.
And so, as you look forward to the next year, what do you think the landscape of open source is going to look like? How's it going to evolve? And then, what are you most excited about at Sentient?
I'm excited to see this new upcoming world models across for small things. I'm excited to see the landscape of open source in terms of science. Uh, I can't believe the kind of science projects which were never funded by any government are being funded by venture capital. This is like the best thing that can happen to science. I'm very excited about that part. And in terms of sentient, I'm looking forward to our own reasoning agents. The agents that we have been pushing up, we have been pushing search quite a bit. We have been pushing up financial agent quite a bit. Soon we will see many more agents, even in the science side. So that's what we are looking forward to.
All right. Himanshu, thank you so much for joining us. You can find Himanshu on x.com/hstyagi and sentient.xyz. Go check it out. And thank you so much. This has been a pleasure.
Thank you, guys.
All right. Yeah, I love that that we're talking so much about open source right now. It's so important and competition is everything, right? And so if we do have open source, we have closed source, and we have a lot of different options for consumers, a lot of different options for enterprise, it's just going to benefit everybody. It's going to benefit the end user most of all, which is great. So I'm
Yeah.
glad we're talking so much about it, and I'm also excited to talk to our next guest as well.
Yeah, I was going to say, speaking of, yeah, well, one of the benefits, the obvious benefits, is just the transparency that you get out of open source. And last week we were just talking about the reputational damage that AI has gone through over the last few months. Transparency is a big part of correcting that, in my mind.
Absolutely. And then also just like I'm a tinkerer, I'm a builder. I want to get the things in my hand. And Himanshu said that. There's like something just about being able to get the thing and play around with it and break it and rebuild it. And it's not the easiest thing in the world to do with artificial intelligence, but you can do it and you can learn it. And I mean, look at PewDiePie, right? Like that's the type of stuff that makes me so excited to see just this guy going on a journey, figuring out like, oh, I'm going to build my own AI cluster at home, and then I'm going to put an open source operating system on my machine. And then, hey, I'm going to train my own models. And I don't know. It's really cool. It's the thing that gets me excited to be in this little industry we're in.
100%. Yeah, it's fun seeing those stories.
Well, let's bring on our next guest.
Without further ado, up next we have Misha Laskin, a former researcher at Google DeepMind and now the co-founder and CEO of Reflection AI, America's open frontier AI lab, which recently has raised $2 billion. So, Misha, welcome to the show.
Hi, Matthew. Hi, Nick. Thanks for having me.
Of course.
Hey, Misha.
Good to see you. Go ahead. You guys may have seen each other last night. Is that right?
We did run into each other. Yeah.
Yeah.
Right,
yeah. How did you like the show, by
that.
the way?
It was really good. It was my second favorite kind of opera I've ever seen. The first one was in Verona, and it's really hard to beat Italy in their own game. So it was I thought it was a great opera.
Yeah. Really, really fun night, really fun show. Let's talk about AI. Like, dive in, tell us a little bit about what Reflection does, and let's just start there.
Reflection, if I was, in two words, Reflection is building the US DeepSeek. So we're building frontier open models of Western provenance. And it's really important to us that these models have, are not just, it's important to have, small models that people can tinker with. That's going to be part of it as well. But even more important is to be able to compete at the frontier. Yeah. And what we're doing here is building frontier open models and putting something out that is going to be competitive with the incredible models coming out of China. And from there, just build frontier models overall that happen to be open.
And okay, so okay, a lot to unpack there. First, like definitely China is leading in open source. Why is it important for the US to lead in open source artificial intelligence?
Yeah, it's a really good question because one could say there is already, there's someone bearing the torch of open models. There are, maybe five Chinese labs that are producing great models. Um, but the what's important here is that it's extremely important that AI is not developed in what I would call kind of a unipolar setting. And it cuts two ways. One, it's important that the world is balanced and that there are powerful models coming from both the US and China. Uh, and two, it's important that like there's one way that AI could develop in the US and in the Western world more broadly today, which is that the only good models are coming from closed labs. And I think that would be a fundamentally negative way for AI, the most impactful technology of our time, to develop. And so you kind of need this counterbalance on both ends. One, to counterbalance the closed labs that are producing great models and produce something that is competitive but open. And two, it's just extremely important that uh, geopolitically that there's more than one source of great open models. Uh, well, one way to think about it is in terms of how uh, an analogy of how enterprises think about cloud providers. One could say, well, AWS is a cloud provider, and you only need one. But the reality is that enterprises want choice, and that's why there's AWS and GCP and Azure and others. And with open models, it's like that, but I would say at a global scale, where entire countries are making decisions around which AI to adopt as they're building out their sovereign AI, right? There was the Saudi state visit that happened this week in DC, and a lot of that was about how to build out the sovereign intelligence for Saudi. And entire countries don't want to be locked into another country. They want choice, right? So it's really important for them that there are great open models coming out from more than one place.
Can you imagine a world, and let's just focus on the US for now, but where all the frontier models are open source? Would that be a good world to live in, or is the counterbalance of the closed source models coming out of other frontier labs equally important for the reasons you just stated around competition and other things like that?
I think about it in terms of markets and which markets require open models and which ones don't, because you don't need open models for everything. Uh, I kind of see there being three markets that can sustain a foundation model company, in the sense that these are three markets that have deep enough capital pools to sustain such a thing. Uh, the first one is consumer, and that's really where, right, OpenAI built its business with ChatGPT. And that's where AI started diffusing, right? AI started diffusing at scale basically 4 years ago when ChatGPT was launched. And then it moved up to startups and cloud APIs with closed models. And that is still, there's no, if you're a startup and you're just getting started and you're three people in a room, you may not want all the complexities that are associated with tinkering with an open model. You may just want its outputs and someone to host it. And so that makes a lot of sense. But now we're moving into the third market. And the third and last market, when you move further up market, you move into large enterprise and sovereign. And at that point, it's extremely important for large companies and sovereign states to have full ownership of their models. And maybe one place to kind of track uh, why that is the case is these startups that started off on closed that have scaled up and are now building on open, right? So Cursor released, for example, a new model called Composer One. It's it's a post train of an open model, and the reason is that they become big enough where they have a lot of interesting data and they want to control their margins and they just want to control their own destiny, right? They don't want to be locked in to basically their direct competitor, which are the intelligence providers. So the way I see the world evolving is that there's a place for both. I don't see it being as kind of one or the other. But right now, outside of China, there is a massive vacuum when it comes to open intelligence. There's not a single competitive model outside of China when it comes to open intelligence. And that's a problem because it means that there are, a small handful of hundreds of people, right, in the world that get to control basically our technological destinies, what capabilities go into these models, the safety guardrails, and they're extremely secretive and everyone's locked out. So it's extremely important that there's at least one or more counterbalances to that.
Misha, one counter argument or argument against open source from the frontier closed source labs is all about safety. And like speak a little bit to that, why you believe open source is safe, how it compares to the safety of the closed source labs, and kind of the general thought of like why open source and why that argument may be inaccurate.
There are two ways that I think about the safety debate around open models. Uh, the first one is that fundamentally what's happening is that there are, again, less than a small, like maybe hundreds of researchers and probably even less than that that actually work on safety that get to see how these models are built at the frontier. And what you're hearing is that those researchers are kind of saying, we'll take care of it, we'll take care of the safety problem and you're welcome. And these things are too dangerous and you can't participate in that discourse because this is something that is our purview. That seems like a fundamentally undemocratic way to approach the safety problem. I think it's much better for the community if any researcher and anyone who wants to contribute to safety as a researcher and to really study capabilities has access to models that they can actually play with and be part of that discourse. I actually, I only hear people inside the closed labs saying that, oh, closed is best for safety. When you talk to researchers at a university, that is usually not what I hear. So it's kind of a convenient position to take. The second thing, though, is that there are powerful open models out there, right, coming from China, and that's going to keep happening. So we're going to a world, whether or not closed model labs like it, that there are powerful open models out there, right, whether they're US provenance or elsewhere. And so you have to think about safety with that in mind, that there will be open models out there, and that we need to think of safety proactively in a world where that exists, right? It's going to be very hard to regulate away the existence of open models because, right, when things are open, they spread quickly. It's so hard to kind of contain that thing. So you have to take the position that these things will exist, and we need to think about safety when they're in the world rather than have a kind of bury my head in the sand kind of approach where you're saying, well, we're going to be closed, and so we're the good guys, and we're not going to think about this problem.
That makes a lot of sense to me. I'm curious, what kind of safety measure guardrails are you thinking about? Do you think makes sense for the industry?
I think there are two things. I mean, one is more on the operational side, and two is more on the research side. On the operational side, these models are going to start getting capable enough that you might want to start thinking through how to actually distribute them, especially the big ones that can cause harm if they're fine-tuned in an adversarial way. And there are measures that, let's say, right, banks have this in place. They have a KYC, know your customer type of measures in place in order to ensure that there isn't like illicit money laundering happening through the banks. And so I think there's kind of an operational side of how to ensure that you're setting up your company operationally to distribute models safely. But the second one is that you have to think about safety not just in terms of the outputs of the models, but you have to think about it in terms of how do you ensure safety, assuming that open models are out in the world. And so I think that means things like fingerprinting, like can you basically track the provenance of a model when it's out, right? So you can at least trace how it got to where it did. I think there are measures around how do you basically research around how do you prevent adversarial fine tuning. This is kind of an interesting idea, but there are, right, one way in which people think about these models are in terms of circuits. And right there, you can kind of think about they have brains, they have neural circuits, and these circuits oftentimes have a superposition of multiple capabilities. So an interesting thing to think about is how can you basically superpose reasoning and safety capabilities together. So you can basically have a smart model that's safe, or then a dumb model that's unsafe, right? That'd be the ideal world. If you can produce a checkpoint that when you basically start removing the safety guardrails, you also start removing the capability guardrail or the capabilities out of it. But it's kind of an open field, and no one's really thought about safety that deeply with open models in existence. And it's just extremely important to have safety teams and lines of research that investigate these kinds of problems.
And Misha, I'm sure you saw the paper out of Anthropic just about probably a week ago where they disclosed essentially a group used the Claude family of models to perform really autonomous hacks. And immediately everybody pointed and said, well, that's the reason we should not have open source models. But like that made no sense to me because it was clearly the Claude family of models in the paper that were being abused. And so given the non-deterministic nature of models, it's almost impossible to fully prevent somebody from even prompt hacking the closed source models to get them to do what they want. And so like I guess what was your reaction when you first saw that? And yeah, what do you think now?
Yeah, well, I think that this is kind of an example of, that particular example is independent of a model being closed or open, right? These models, when you have capability, adversarial actors can use them for illicit purposes. And so whether it's closed or open model matters less. I think with open models, right, an adversary could post-train them to be particularly good at something nefarious like this. But I think the general safety problem is kind of independent of closed and or open models. And probably the biggest vector of attack, I would say, when we think about safety is probably not a Terminator-like situation, but more in cybersecurity. Like I suspect that the biggest surface area of attack for language models today, and probably moving in the near future as well, is making incredibly effective, basically hacker agents, and right, obviously wanting to combat that with defensive cybersecurity agents as well.
And so, okay, as you continue to build Reflection, what are the major components aside from putting out an incredible frontier open source model that you need to build to have a long-lasting, sustainable business?
That's a really good question, Matthew. So the way I kind of think that the first level of abstraction is, what does it take to build a frontier lab or a new frontier lab? Because that's kind of the journey you have to go through in order to produce frontier open or closed models. And you basically need three components. You need the talent to build these, and not just quality, but sufficient quantity of high quality talent, because these are mini Manhattan projects effectively, and they require a lot of very talented people to be working on them from pre-training to post-training. The second thing is that, well, you need obviously compute and capital. So without a certain requisite amount of compute, you can't even get started. And the third thing is you need to have a commercial opportunity that is large enough and has deep enough, effectively revenue generating opportunity that you can continue playing this game. And without any one of those three, you cannot do it. So what's really interesting about open intelligence is that I think a year ago, let's say even 2 years ago, I think the year ago, 2 years ago, the talent and the compute were effectively there, right? You could assemble a great team around this. I think that it's a mission that really inspires a lot of AI researchers, because we got into this as scientists. Like for us, there's no such thing as open science; it's just science, right? And so the team, I think, has not historically been the problem. The kind of compute and strategic backing, I mean, right, Meta had a lot of compute, and so I don't think that was a problem either. But the commercial opportunity has always been a problem. And what's changed is that as AI has diffused from consumer to startups, through cloud APIs, and now to large enterprise, now is the time when there is a commercial opportunity that didn't exist before. Now as large enterprises and sovereign states are building out AI factories, which are basically data centers that have GPUs, and they need to run models to serve intelligence into these sovereign and large enterprises. Well, you can only really do that with an open model, right? Because they want to control their intelligence, they want to own it. And so the commercial opportunity didn't really exist until now, because AI has kind of diffused far enough into large enterprise that there's a lot of demand for open models. And so that's why it's possible to build a new frontier lab today, which we believe to be the last frontier lab, because when you think about these three markets, there's no other market. Like these are the three that you can't go further up market than sovereign states. And sovereign states and large enterprises have a strong preference for consuming open versus closed models. And there's a large surface area of commercialization opportunity there, because obviously enterprises look, they don't, they're not thinking about tokens or models, they're thinking about solutions, right? And so the way to think about it is that we're building the brain that's going to power these AI factories that are distributed into large enterprise and sovereign states. And obviously there's a lot of opportunity around, commercializing the services and products around that brain.
And Misha, I mean, you said it perfectly. They don't really care about the details. They want the solution. They want the solution to their problem. And I think ultimately that's probably just a factor of speed, cost, quality. Does it come down to that? They don't care if they're hosting it themselves, or maybe that's challenging for them, or it's being served by Reflection. Like, is that typically the pitch? It's like, hey, we're just a better, cheaper, faster model.
The interesting thing about enterprise is that there's a confluence of kind of multiple benefits that make this an overall kind of a better value proposition. Something that we've done as a company is we've kind of produced, like, as we've gone to market and talked to customers, we produced this slide that is like, and it's important that the slide is ugly so that customers resonate with it despite its aesthetics. So it's like a slide, Times New Roman, like font, present like 4 to 6 kind of pain points that you're solving for customers. And the point is to iterate on the slide for as long as necessary, so that when you show it to a prospective customer, within the first few minutes of seeing it, despite it being a very ugly slide, they're extremely excited about what you're doing and engaging with you. And so the points on this slide, one of them is what you mentioned. So one thing that's really important to enterprises, and again, large startups, right? Like as we're seeing the adoption of open models in startups like Cursor, is cost control. And by that, I mean the predictability of cost. Once you're a big consumer of intelligence, tokenomics don't really make sense, because it's a high variable cost. You're a CIO, you want to know exactly how much you're paying for your intelligence in a given year, right? Maybe you're okay with 100 million, but you're not okay not knowing what it's going to be, right? Yeah. You're not okay with it ballooning from 100 to 300 million because agents got smarter and you basically had this high variable token cost. So the ability to predict costs and have, right, there's cost efficiency, but there's cost predictability. That's extremely important. The ability to keep your data within your own data plane and not have to send it to a cloud model provider, right? To really just keep that all within your infrastructure is extremely important. The ability to not be beholden to any particular cloud provider as a large enterprise, right? So that you're not beholden to AWS and their suite of products, or GCP and their suite of products, that you're multi-cloud and that you are really kind of, not locked into any one of these providers is extremely important. And then the ability to customize the models so that they are either better at data that is basically off distribution for them that you have, or much more cost efficient, or much faster. Like, there are many kind of degrees to customizability, but you can only customize something when you have an open model, right? That you can tweak, tinker with, fine tune, and post train. And so it ends up being this kind of confluence of factors that make open models, despite the potential friction of setting them up, right, a massive benefit over closed for large enterprise.
Misha, I'm sorry, I got to go back to this slide. Very curious. So it started out as a beautiful slide, and the team said, hey, these customers are just nodding along. They're not really getting it. We got to make it uglier. Tell us about how this all transpired.
Well, the slide never started beautiful, I think.
Okay, it started ugly. Fair enough.
Yeah, it started ugly and stayed ugly.
It got uglier.
But it started, right? It starts when you don't, when you have limited customer discovery, you kind of only have, you're guessing about what you think is going to be important to them. But as you have many conversations, right, and you ask questions, you kind of see where's the kind of emotional buy-in of people, like what is exciting to them and what will make their life easier. And then you iterate on this a number of times until you get it to something that lands really consistently among a target customer group, right? Different customer groups have different things. Like scaled up startups care about different things than a large regulated enterprise, different thing than a large sovereign customer. Um, but yeah, it was not intentional to make the slide ugly. But we're researchers and salespeople and not designers. So I think that that was just a byproduct of our skill set.
Misha,
I remember.
talk.
Oh,
Oh,
go
go
ahead.
ahead, Nick. Sorry.
I remember years and years ago, we were running this campaign at this small startup, and we had all these beautiful ad placements, and the campaign wasn't doing super well. And someone was like, "Hey, we should just like make the opposite of what these images are." And so it ended up being this like big impact font, bright yellow colors, this terrible like ad placement, and it performed better than everything else. So anyway,
Mm.
I think there's a lesson here. There's performance in ugliness. Something
Yeah,
like that.
probably. I mean, and maybe, when you go and look at, I don't know what it's like now, but I remember when I was in academia, you go look at any professor's site and it's like, it looks like it was built in, 1999 or something like
Right.
this. And there's something
Yes, it
charming
is. Yeah.
Paul
Misha,
Graham's site. Yeah.
Misha, before we let you go, I want to just ask one last question. Like, where is Reflection in its journey in your mission? And then what do you like? Can you give us a little bit of hints as what's coming?
So we've obviously capitalized to get the requisite compute to
Yeah,
train, to
congratulations.
pre-train and post-train. Thank you. Pre-train and post-train, end-to-end, an American open model, right, that we can export to the rest of the world. And assembled an incredible talent bench around it. We have, a really kind of solid critical mass of people who led this work at Frontier Labs, from leading post-training modeling and data efforts, pre-training modeling and data efforts to reasoning on post-training and coding on post-training and RLHF on post-training. We kind of have key people who've led all this work across the entire stack of language models. And built out teams right around them. Uh, and so I think we're kind of in a really good place from a talent and capital perspective. And so we're on what's called, this is what every Frontier Lab goes through. And people call this the scaling ladder. And it's effectively where you're methodically training these models from small to large scale, because at each scale, things fundamentally change and break in new ways. And I know there's this term in AI called, right, doing YOLO runs. Like there's this, I think, popularized, I forget, maybe by OpenAI or something. And I think that is primarily only works really in post training. Like post training is this kind of wild west, and there's like a lot of, I think, diversity and experimentation. Um, but as one of the team members says at Reflection, like you can't YOLO pre training. It has to be extremely precise and methodical. And so you need to go through the scaling ladder in order to get there. And so we're going through that right now. We're seeing some really exciting initial results, and we'll be releasing some great models next year.
And Misha, it doesn't sound, especially like with Gemini 3 being released this week, that the scaling law is slowing down or seeing a wall anytime soon. Is that kind of your understanding?
I think so. I mean, the thing is that you can pack so much intelligence into neural networks. I think people still, it's just hard to internalize that. That's kind of when people started feeling the AGI in these frontier labs well before there was anything that looked remotely like AGI. And at least for me, it was the AlphaGo moment when AlphaGo discovered a new move in the game of Go and became super intelligent, but memorialized in this move 37. And it was a tiny neural network. It was like a 60 million or something like that, parameter neural network. And you can pack so much intelligence into it. And so the entire game is how do you make, incremental progress on pre-training and post-training? And sometimes there's a breakthrough that comes through, but a lot of it is incremental gains that compound in interesting ways. And, and you can pack so much intelligence to these models. It's just a matter of how. So I don't expect us to hit a wall really, anytime soon. It's just a matter of how do I pack kind of more intelligence into these parameters.
And sorry, I do have one more or another question for you if you have another minute. As you like looking at world models, where do they fit into the open source landscape, and where do they fit into the kind of the leading up to AGI path?
And when you say world models, you mean kind of multimodal models, kind of both text and pixels?
Yeah, like what's coming out of Fei Li's lab, for example. Uh,
Yeah. Well, I think a world model is when we kind of go kind of before foundation models and LLMs, a world model is just the thing that, given your current observation, right, and an action that you might take in your environment, you can predict what the next observation is going to be. And that is to say that language models are in themselves, they are world models, like because they're predicting, right, that they're world models in text, right? Now there are world models, next token prediction in uh, right in video as well. And I think some of the really exciting stuff around that has been, yeah, what Feifei is working on, but the Genie line of work coming from
yeah.
DeepMind has also been
Yep.
extremely exciting. Uh, and I think that that kind of goes back to the previous point that there are so many clever ways to figure out how to pack kind of more intelligence into these things. And right, the big thing that was solved is how do you, when you have large scale internet data sets that don't have actions in them, how do you infer the actions that were taken to build world models? And clearly that breakthrough was achieved with Genie and some what Feifei is doing. So I think it's all really exciting, and you'll probably just have. I do think there will be like just general, multimodal models that have kind of world models baked into them, uh, and that capability is just going to continue increasing.
Misha, thank you so much for your time today. Really appreciate it. Super interesting conversation. Keep up the amazing work building American open source. You can find Misha at Misha Laskin on X and obviously reflection.ai. Go check it out. Misha, thank you so much. Join us back again, please.
Thank you, Matthew. Thank you, Nick. See ya.
Thank you,
All right.
Misha. Talk soon. All right. Well, Matt, let's keep this party going. On to the next guest. We now have Bryan Catanzaro, Vice President of Applied Deep Learning Research at NVIDIA. Bryan was actually a major force behind the adoption of GPUs for machine learning, which, as you might know, helped NVIDIA go from a relatively small graphics hardware company to the $4 trillion behemoth that it is today. So, Bryan, welcome to Forward Future Live.
So glad to be here.
So, before we get into everything that is happening today, there's a lot to talk about there, obviously. Take us back to the very beginning when you first joined NVIDIA. What did it look like? What did it feel like? What did it smell like? And what moment, what was the moment that really pushed the company to make this big bet on GPUs or machine learning, that is?
Well, yeah, so I was a grad student at UC Berkeley, trying to figure out how to accelerate the world's most important computations, whatever those would be, back in 2005. And NVIDIA came out with CUDA in 2006, and they came over to my lab and said, "Hey, you should try this out." And so I plugged it into their GPU. I plugged it into my computer, and I rewrote my support vector machine training code that I had been working on for months on an FPGA. I rewrote it for the GPU in like 30 minutes. And I was like, oh, that was easy. And then I ran it and it was like 200 times faster than my CPU code. And I was like, that was it? Wow, this is so much easier than what I was doing before. And um, so I had this kind of light bulb moment that, it was going to be possible to dramatically accelerate machine learning with GPUs back in 2006. And so I joined NVIDIA as an intern in 2008 in the research group, which back then was very small. There's probably 15 people in the entire research department at at NVIDIA, and it was a different company. It was a company focused on graphics for gaming generally, but there was this hope that accelerated computing, this sort of business of understanding what the most important computations are, and then figuring out how to build hardware and software to deliver, 10x, 100x acceleration was going to lead to transformational results for something beyond graphics. And I had this strong belief that that was going to be machine learning and AI because I felt like the amount of compute that we need in order to make intelligence is essentially unbounded because the amount of intelligence that we need is essentially unbounded. And so I started work at NVIDIA full time in 2011, hoping to do that. At first, it was a little bit of a slog because you guys might not remember back then, but AI was old in 2011, and especially neural networks were old.
Yeah.
I think the first neural network was published in like the 1950s by some Soviet researcher, right, or 1960s. So this was an old idea. It was an idea that many people had spent their careers trying to make happen, and it hadn't. And so there's a lot of skepticism back then about whether deep learning could actually scale, whether it could solve new kinds of problems, whether it was really a different form of AI or whether it was just a kludge. A lot of people back then believed that that deep learning was inelegant and kind of stupid, and really what the world needed for better AI was more complicated math. And that was kind of how the field was structured back then. But then, AlexNet happened, totally revolutionized the field of image classification, which, just astonishing progress in a short amount of time because really of training larger models on larger data sets with GPUs. And so that got people's attention and it drew a lot more support for my research. I had been working on a prototype of a library for convolutions on the GPU, which then later the company decided to turn into cuDNN, which was our very first AI software library. And the process by which that happened, it was slow at first and then fast. I think that's how most hockey sticks feel. Is like nothing, 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 all of a sudden
Yep.
in it, right? And so there was a moment in 2013 when all of a sudden it became clear to NVIDIA's leadership and especially Jensen that this was the place where accelerated computing was going to have its biggest impact. And the company never looked back. Jensen pulled me into a room and said, with a lot of other leaders in the company, and said, and at the time was just a fairly junior researcher, so I was like kind of odd just to be in the presence of all these like important people. And Jensen said, all the work that's happening around the company right now is not important. It's as if they were just standing around in the parking lot doing nothing. I want to consider everything that we're doing as something that we can sacrifice in order to focus on this. That was in 2013.
And no
And
pressure.
uh, right. No pressure, but it was a big opportunity. And I remember back then we were trying to figure out like what's the total addressable market for AI, and we did all these bottom-up calculations and got to these numbers, which seemed absurdly big at the time, and now in retrospect seem absurdly small. But how did NVIDIA feel? How did it smell? NVIDIA was much smaller back then, probably 10x smaller, maybe 5x smaller than it is now. But the culture felt very similar. And in fact, a lot of the leadership is still the same. Jensen is still there. My boss, Jonah Albin, an absolutely incredible leader here at NVIDIA, he's still making the GPU awesome. So there's a lot of longevity in this company. This is a company that plays the long game. CUDA took 20 years to matter, but we kept investing in it because we believed AI, we've been working on it for a long time before we were a multi-trillion dollar company. And we're going to continue working on it because we still believe. And so I think NVIDIA's culture has remained fairly consistent even as the company has grown. It's a culture that prioritizes working together as one team, which is required. If you think about the business of accelerated computing, we're not selling a chip. NVIDIA, although we make chips, and we sell them, that's the sort of the physical monetization that we do for our business. What we're actually selling is capability. We're selling time. We're selling to researchers and engineers the ability to build things that they could never build before. And that's far more valuable than any computer ever could be, but it's also far more ambitious and it requires far more kinds of technology to work together in order to deliver that acceleration. If any
Yeah.
piece is missing, if any link in that chain of hundreds of different kinds of technology, ranging from transistors to compilers to libraries to algorithms to applications, if anything along that line doesn't deliver, you don't deliver acceleration, your product is not valuable. And
Yeah.
so that requires collaboration at a scale that I think is very difficult to achieve. It's something that I'm proud of about NVIDIA's culture, something that I don't take for granted, something that we're always trying to do better is how do we think about our work as one body of work and work together as one team to provide acceleration for the things that matter most.
So CUDA is an incredibly important software ecosystem. It's a part of how you delivered accelerated computing. Can you talk a little bit about that relationship, how you see it between the hardware and the software, and why that close relationship between the two is so important?
Absolutely. I mean, as I was saying, uh, what we're selling is not a system, we're selling a capability. We're trying to make it possible for scientists and engineers to build things that could never be built with traditional computing systems. And so the entire problem has to be jointly understood and jointly optimized in order to deliver that acceleration. And CUDA is so much more than the programming language that people think about. It's also drivers, it's compilers, it's frameworks, it is applications. It's an entire ecosystem with millions of developers that are building applications to use CUDA. That's all part of what makes CUDA special. And these days, I think one of the most important things that we're doing with CUDA is continuing to broaden its reach by working with cloud computing providers of all different shapes and sizes around the world to make sure that when you rent time on their cloud computing systems to train or to deploy AI models on NVIDIA systems, that you get absolute maximum speed. It turns out that that is a very difficult thing to do. It's difficult to build a data center. It's difficult to get the networking and the storage and all of the different moving pieces that make an AI factory work lined up. And that's an investment that a chip maker would never make, right? A chip maker would be like, "Hey, we're selling chips. Have fun. Go put them in a building somewhere. Not our problem, right?" But at NVIDIA, we are working really hard. In fact, like all of the AI models, all the Nemotron models that we build here at NVIDIA are trained on DGX Cloud, using systems that are being built and deployed by others. And that is a lot of work for us because we have to figure out how to make all these different kinds of data centers work. We have to debug them, figure out how we're going to interact with them so that we get absolute maximum speed out of them. In the process, we're making CUDA stronger, right? Because all of the investment that we make to improve the customer experience as they use the cloud with NVIDIA systems for our own purposes, we hope, we know that it also helps our customers when they do the same thing. So CUDA is so much more than a library or a programming language. It also these days extends to the entire fleet of AI factories around the world that we're working with.
And Brian, NVIDIA is such a big proponent of open source, and you quickly mentioned Nematron, but I want to stay on that for a moment. Like for those who are watching who may not know what Nematron is, like give us the breakdown of what Nematron is, why NVIDIA is building it.
Nemotron is our NVIDIA's AI models and data sets and techniques. It's really key to what we're doing here at NVIDIA. So it has two main purposes. The first purpose is to help us figure out how to build accelerated computing for the future. Accelerated computing is actually really about deceleration, if you think about it. Nobody wakes up in the morning and says, I want a slow computer. Could somebody build me a slow one, right? So acceleration is really about focus. It's about deciding what are you going to make faster and then not worrying about the other stuff, right?
Hmm.
That is the core insight behind accelerated computing. But how are we going to do that for AI if we don't know exactly what AI is? There are critical questions about things like batch sizes, numerical precision, model architectures. For example, How are we dealing with attention? How are we dealing with mixture of experts? How are we dealing with networking? Uh, how are we dealing with the different pieces of the GPU? The GPU has evolved to be much more efficient at AI computation over the past decade. We need to make it even more efficient, right? So, how are we going to make those decisions and design the systems of the future without deeply understanding everything about what goes into making AI? So that's Nemotron's first job is and something that we have to do to continue developing our core product line is to deeply understand AI. Just two examples for that. In the past year, we have accelerated our Nemotron pre-training by a factor of 4 just by improvements in the pre-training data set alone. So what do I mean by that? I mean the amount of GPU time that it takes to get any model to a certain level of accuracy, we have accelerated by a factor of 4 because of improvements to our pre-training data set, making our pre-training data set cleaner and smarter, basically packing more intelligence per token into our pre-training data set. Now, that is faster than Moore's Law, right? We are accelerating pre-training here at NVIDIA faster than Moore's Law by improving our pre-training data set than by the GPU itself, right? Um, so what's the implication of that? That means that like if we are not having world-class pre-training data sets, we will not be able to explain how to make pre-training faster because the if you're accelerating something that actually doesn't need to be accelerated because you're solving the wrong problem, you'll build the wrong thing. So that's one example that these days AI is part of accelerated computing. You can't really think about the process of accelerating AI without having world-class data sets and world-class models. A second example, NVFP4. So in our Blackwell GPU generation, we have a really interesting 4-bit floating point format. It's a little bit more than 4 bits because there's some block scaling factors and so forth that go into that. And we have shown that you can pre-train AI models using 4-bit arithmetic and get excellent world-class results doing that. Now, the implications of that are pretty big because that's going to save a lot of energy for people pre-training models, which then is going to allow them to pre-train larger models, which are more intelligent. We wouldn't be able to show the value of that Blackwell feature without having, amazing Nemotron models to show the world that we are training using the latest and greatest features of Blackwell. So that's Nemotron's first job is like, how do we design the systems of the future, make sure that we're doing that in a way that's important and resonates and will solve the needs of the future for AI, and show people the value of the systems that we built. Now, oh, go ahead.
Oh, I was just going to ask, as you're doing that, what are the challenges that you foresee coming up as you go through that process? Are there things that you're tackling right now, or that you're anticipating will occur that you need to make sure that your team is ready to handle?
I mean, it's just challenges everywhere. I mean, everything is hard, nothing is easy. I mean, if you just look around the world right now and how many gigawatts are planned to go into AI training and deployment, it's staggering. And the implications of that is that the pressure on efficiency is greater than ever. Like we can't afford to waste a single watt. And we've got to figure out how to use our compute much more efficiently. Now, this is business as usual in some sense. Like NVIDIA has been in a power constrained mode for more than a decade. It's been true that the ultimate acceleration that we can provide is critically dependent on our power efficiency. However, I think that the scale that we're working with now is so much bigger than we've ever worked in the past as a civilization. Our computing infrastructure is growing so large that the importance of efficiency is greater than ever. So that's something that I think about a lot. Maybe something more connected with model architecture that matters a lot to me is how do we compute attention? So attention famously is all you need. For everybody working with modern AI, except that it's a quadratic algorithm. Oh, we don't like those, right? That's not efficient. It also has a lot of implications about memory usage. So when we deploy a model, the KV cache, the size of the KV cache can be a limitation to the efficiency of the deployed model because if you're spending a lot of memory holding activations, you can't really run at large concurrency factors, and then that is going to kind of starve the processor of compute, which isn't good. So we need to make attention smarter. And that's one of the things that we've been doing with our recent Nemotron models is using hybrid transformer and SSM attention approaches so that we can make the model much more efficient during inference. So that's probably one of the biggest challenges that I think we face and we're going to continue to face.
One, Brian, of the biggest kind of reflections of that kind of quadratic limitator is the fact that the context window seems to be the growth of it is pretty stagnant now. How do you think about growing the context window? How do you think about, is it critically important? Do we have enough context for now for most use cases?
You get different answers to that question from different people and different applications. I think that is a critically important question. So that's something that I'm constantly trying to investigate for myself. I think for a lot of applications, we're actually doing pretty good. 256K tokens seems like a pretty nice number. But, how do we get to 2 million and what kind of use cases would be unlocked? I think, you know, we are going to want the ability to reference more information. It's going to be hierarchical and sparse. At some point, the line between a long context window and retrieval augmented generation, like RAG systems, becomes a little blurry because, if you have a sparse attention, like you could think of RAG as sparse attention, right? It's just like RAG is like a really, really sparse attention. But like, what if we had a sparser form of attention that we were applying to a much larger explicit context window? Could we do something better? One application that's always been on my mind that I think needs larger context window is much more personalized AI that understands much more about me. And for example, like an AI that understands all of my emails, it's read all of them, it's read all of my responses, it understands all my text messages. This is the kind of AI that would be incredibly valuable to me, but also incredibly sensitive, right? Because it's like the more that a model has access to, all of the information about me, the more power it has to understand my life, and that I'm going to want to protect that model. I think that ultimately we're going to want to move towards models that have that capability so that we can each have AI that is much more helpful. And I think figuring out how to deal with more information so that the AI can access more about each of us personally is going to be transformative. How are we going to do that technically? I do think that's an open research question.
And Brian, I asked this of a previous guest. I want to get your thoughts on it as well. I think some folks in the industry think true generalization requires dynamic updating of model weights in like real time. Do you think that's the case? I mean, it's kind of the flip side to extending the context window.
Yeah, I'm personally less bullish on that. I think that's a lot of complexity. It's the amount of like work that we do right now once we train a model just to get it through our safety evaluations and make sure that the model is safe to use is fairly large. And I would be quite concerned about how a model that's being dynamically updated is going to um, uh, be aligned with our values. So that would be a thing that I feel like is an unsolved question. I think if you have a model that's very generally intelligent and it has the ability to read all of my emails and all of my text messages. Maybe it doesn't need to be dynamically updated because it can reason given new content, right? Like new content can go into the query rather than retraining the model.
Okay, and another question on Nemotron. It is open source in the truest sense of the word. Why, like, what was the decision behind that? Like data sets,
Yeah.
training process. weights, like every single part of it is completely open, completely out there. Talk a little bit about that.
Yeah, well, so I wanted to tell you about Nemotron's second job, and that is connected to that question. So let me tell you about
Please.
Nemotron's second job, which is really to help AI flourish around the world and be deployed in all sorts of new and interesting ways. So, um, you know, uh, NVIDIA is a different kind of AI company than any other AI company. We're the only AI company that partners with everyone. We partner with AI native companies, we partner with hyperscalers, we partner with startups, we partner with established companies, we partner with companies in healthcare, in manufacturing, every sector of the economy, every shape and size all over the world. And the reason we partner with them is that our business has an opportunity to grow whenever AI grows. And that is a different kind of AI business than any other AI business. NVIDIA does not try to control directly how AI is deployed. We believe that our job is to enable other companies to do that. We're here to support. And so when you think about that orientation, that naturally leads to an open development process for Nemotron models because we know that institutions and organizations around the world will be better able to use the technologies that we're creating and benefit from Nemotron. We'll be better able to support them if they can see what's going into this AI, if they can see the data sets, if they can customize the models, if they can deploy them in a manner that makes sense to them so that they can safeguard their data, safeguard their particular access to their customers and to the problems that their business is solving. And so, that's a unique perspective on how AI should be developed. At NVIDIA, I think we see AI more of an infrastructure problem. We're an infrastructure company. We see AI as critical infrastructure like the internet. If you think about the internet, how did it transform every part of the world economy? Well, they were all different, right? It is not a one size fits all thing. The way that healthcare was transformed from the internet was different from the way that retail was transformed by the internet. And so, we see AI transforming every part of the world economy, but we want to support every organization to use AI in ways that make sense to it. And that's why we're developing Nemotron in such an open way.
Apologies. Bryan, thank you so much for joining us. It's been an absolute pleasure. You can find Bryan CTNZR on Twitter. Go get the Nemotron family of models, play with it, download it, have fun with it. Developer.nvidia.com, and come back anytime.
All right. Thank you so much.
Thanks, Bryan. See ya.
That was a good one. Feels like we could have gone on for maybe a couple more hours. Plenty to learn from Bryan.
I mean, it's crazy to think like he was there at the like inflection point of AI as part of NVIDIA in the earliest days that they were kind of identifying AI as the next big opportunity, and he was in the room with Jensen talking about it, and just wild.
I had heard, I had read during my research, and I don't know if there's any merit to it, but there's something about him getting 30 very technical, long form emails from Jensen every single day. Really wanted to ask him about it. Didn't get a chance. Next time. All right, folks. For our final guest, we have Robbie Stein, Vice President of Product for Google Search. Now, he oversees core features like AI overviews, AI mode, and on the heels of Gemini 3 launch, we obviously have a lot to talk about there. So, Robbie, come on the show. How are you today?
Hey everyone, how you doing?
Hey, Robbie.
Doing well. Thanks for having me.
Yeah, good to see you. I mean, first, obviously, like congratulations. What a week for you, for Google. Just absolutely stunning model. And it's really exciting.
It's really exciting. It takes a village, a very large village, but it's an exciting week for sure.
So actually on that topic, I have a question about this, because for a little while there, it felt like Google, dare I say, was almost becoming this slow moving company. And then almost overnight, like it feels like that completely changed. And if this week isn't a testament to that, I don't know what is. But you guys are shipping at this like blistering pace now. Yeah. What was that shift like internally? Like, did you see it? Did it happen overnight? Was it a slow burn?
I mean, I think like it's been a build over the last few years. I think, at least from my perspective in search, we believe that there is such a unique opportunity to let people ask truly anything in search and have all of Google's knowledge and information and access to what the best content is on the web for you, just be right at your fingertips. You can ask natural questions with AI, you can take photos. It just seemed like an incredible opportunity. So that motivated us with very high intensity and urgency to shift the product so we could just do so much more for people faster. And then by starting with AI overviews, which was this fast overview, like at the top of the page, then building towards AI mode, which really just let you go right to the AI product experience with a more powerful model and a multi-turn kind of search conversation, kind of like built our way towards being able to ship a frontier model in search day one. And so that was like, from my perspective, and every iteration and generation of the models and the products, it's really just a testament, I think, both to the product teams and the core modeling teams on GDM and obviously Demis and Corai's teams that really have just relentlessly improved the product and the model as we've done on the search product, so that each successive release you get these big jumps, and now you can get to the point where you can ask almost anything right in search and get a really high quality response with a frontier model that can think, can reason, and can even generate the page for you, which is, pretty incredible from where we were just 2 years ago.
Yeah, and okay, so just to kind of say it again, this is the first time where a frontier model has been released on essentially like many of Google's products at the same time, basically getting in front of billions of users immediately on day one. And before we get into the details, talk a little bit about the days leading up to the launch and kind of the energy inside Google.
Yeah, I mean, it's an exciting, furious time when you're building new models. Obviously, we were building a version that we launched in AI mode, which was an opportunity for you to use Gemini 3.0 Pro that included generative layouts. And we were building on this version of AI mode internally, starting to use it and seeing what it could do. And really, the insight was, how could you let the model that's so powerful now just have more control over what you see? And so instead of trying to say, hey, generate like a text response that is information about XYZ, it's more about what's the best response for someone trying to learn about how you could do something like learn about lift in an airplane. And what we found was it would do crazy stuff because it has agentic coding. And so a bunch of internal team members were sending around all these links of how it could generate, like on the fly, an interactive simulation of a wing with all of these arrows flying at it, like vectors. And then when you change the wing on a slider, like the whole vector space would move around the wing and it would show lift up or lift down. It was kind of unbelievable. And like, that is really neat. Or if you had a visual question, it would kind of construct the page with more visuals on it. And so that was the kind of aha moment as we were building it, that felt like it was going to be really exciting and new and novel. Obviously, it's still very early in what these models will be doing. And obviously, we work very closely with the GDM team, so we're kind of working with them in a very co-working dynamic. We're sharing stuff we're seeing. They're shipping new versions of the models, et cetera, internally. And there's just a lot of excitement kind of building towards this moment where it's available fairly broadly.
And it's such an interesting concept to have a dynamically generated user interface presented at search time. Like obviously there's, these models are non-deterministic and they hallucinate occasionally, much less than they have even a year ago. But like, how do you protect against that? How do you make sure the AI, the core experience of searching on Google remains consistent and high quality?
Yeah, I mean, the good news is, like, this is not well, AI and generative AI in this way is frontier. Thinking about quality systems for information is something that's happening 20, 25 years. And so it's all of these AI systems are built on top of those. So there's just like an incredibly rigorous approach to understanding, for a given question, is this good information? Are these the right links? Are these the right things that a user would value? What's all the signals and information that are available to know what the best things are to show someone? That's all encoded in the model and how the model's reasoning and using Google search as a tool to find you information. So it's building on that history. It's not starting from scratch, because it's able to say, oh, okay, like, Robbie wants to go on this trip and is looking up cool restaurants in some neighborhood. What are the things that people who are doing that have been relying on Google for all of these years, right? We kind of know what those resources are. We can show you right there. And so I think that helps a lot. And then obviously the models, now that you release the constraint on layout, you obviously, the models over time have also become just better at instruction following as well. And so you can actually just define, hey, here are my primitives, here are my design guidelines, don't do this, do this. And of course it makes mistakes at times, but I think just the quality of the model has gotten so strong that those are much less likely to happen now.
And Robbie, as search is evolving, as the results are changing and really again becoming dynamic, what signals are you looking at to know that the user is not only getting what they want, but that is the best experience possible for their search?
Yeah, there's a whole battery of things. I mean, we look at, like, we really study helpfulness and if people find information helpful. And you do that through evaluating the content kind of offline with real people. You do that online by looking at the actual responses themselves. And are people giving us thumbs up and thumbs downs? Are they appreciating the information that's coming? And then you kind of like, and are they using it more? Are they coming back? Are they voting with their feet because it's valuable to you, right? And so I think you kind of triangulate any one of those things can lead you astray, right? Like there's lots of ways that interestingly, in many products, if the product's not working, you may also cause you to use it more, right? And in search, it's an interesting thing. We have a very specific metric that manages people trying to use it again and again for the same thing. And we know that that's a bad thing because it means that they can't find it. So you got to be really careful. But I think that's how we're building on kind of what we've learned in search, so that we really feel good that the things that we're shipping are being useful, are being found useful by people.
So there was this launch date, a moment in time where we're putting this thing out to the world. Like what was like the specific moment during that lead up where you're like, I have confidence that this thing is actually going to perform really well?
I mean, I think it's mostly this internal usage. I mean, it's so silly. Like you have these, you have these evals and benchmarks and standards that you see, and obviously that's one way to know, wow, this is a very strong model. But how it shows up for people is ultimately how they judge, the performance of these products for everyday use. And we were starting to use it just internally, and you just kind of see people in our chats and our threads just sharing links and experiences of crazy things that it was doing for them. And I think that, I mean, it sounds silly, but those anecdotes and little moments are actually how I build the intuition around product. Because I've also seen the opposite in early versions of other products where you get all problems and all things that it's not doing well. And obviously you go fix those, and that's how you make the product better. But that kind of just it gives you an intuition that people might find a lot, some of these pieces exciting. It's still super early, by the way. Like this is very early days in how these models are going to work and build things for you. But it kind of gave us this glimpse of optimism that there's something here that's going to hopefully be useful to people.
Yeah.
And Robbie, the entire nature of search is really changing, and my relationship personally with how I search is changing drastically. And you're giving Google is giving information directly, and so like, how does that change the monetization framework when you're not necessarily serving ads and you're just giving the answer directly? How does Google think about that?
Yeah, I mean, the way we think about it is search AI and search from what we've observed is highly expansionary. So it's really introducing these like new needs. The everyday searches that people do haven't really changed. Like people still need to, pay their taxes. They need to look up a phone number. They need to go get a quote from a very specific insurance company. And those things are largely the same. But now you can ask this long question. We're on this trip. My friend has an allergy and we're trying to sit outside. One of them has a dog. Where could I go? And in that kind of a case, like there is no anything like specific place that has that information. And so what we think about, since we're search, is we construct this helpful response. It searches under the hood. It gives you some context, but it also provides links, resources, ways to go deeper. And what we're seeing is that people want to be doing it. They want to verify information. They want to read reviews from experts. They want to see photos of the places before they go. And those all create other moments to connect you to the web. They also allow, I think, opportunities in commercial journeys. Like obviously people want to shop, people want to they want to price, they want to understand, should I buy this versus that? I think a big part of AI is getting advice and recommendations for things. I mean, we think over time, there's a great opportunity there, from a business perspective, to make more of those connections even more relevant to you, because you're actually articulating much more of the need that you have. I mean, so we have some experiments going in that direction. They're early but exciting.
Yeah, it feels like if you compare just keywords to input on a chatbot, input field, like the level of not only detail that you get, but also the intention behind it is so much greater. And so that intent data allows advertisers to almost create a better advertising experience for the end user, relevancy, timeliness, all of these things. Do you think we're like on the precipice of entering into a world where ads are actually really appreciated by the user? Like,
I
is that
do.
a potential future?
I do. And I think you hear about all the time, on platforms, people saying like they look forward to getting ads in many places in many times. When it's the right ad, that's the right thing. It's like there's this 20% Black Friday sale from your favorite clothing, apparel brand. And
That
you
you were
get
just
like an
talking about
early
with your
you were
wife, and
yeah, you
yeah.
were just searching for it, you were just doing it, and you have an early look at it. You're like, wow, that's awesome. It's so helpful. You're like trying to
Yeah.
like there's a kind of context that you have kids and you're searching for things for kids, and all of a sudden here's trending, holiday presents that are for 7-year-olds because it knows that I have a 7-year-old, and it can be more useful in that case. So I do think these things are best when it's really the most helpful. It's just like helpful content, like anything.
Yeah, and Robbie, it's interesting. There's an anecdote from earlier in my career. I used to do a lot of digital advertising, and whenever I would talk to my friends, they would always say, "Well, I never click on ads. Who actually clicks on ads?" Well, actually, a lot of people click on ads, and in fact, it's when you click on them and don't kind of think about, "Oh, this is such clearly an advertisement." It's that very natural experience where it's extremely targeted, extremely relevant for what I need in that moment that you forget it's an ad to begin with. Um, I wanted to ask you, we talked about this a few weeks ago. I wanted to ask you again. It seems like more and more we might be heading in the direction in which, like, I do a Google search, and let's say I want to find the best dog food. I search for the best dog food, and Google not only presents me with that information, but it can actually go on and complete the task of purchasing the dog food for me. How far are we away from that? Do people want that? What are you thinking about at Google?
Yeah, I mean, I think about it a lot from just a pure user value perspective. Like, where's the pain point? Where are you most suffering in that? What's annoying about that? And we focus there first. So actually, in that journey you mentioned, I think actually in many cases, most of the time is spent in the consideration of like, what dog food should I get? Like, do you want it to be healthy? Do you want, how expensive is it? Does it need shipping? And does it need to be on auto ship? Is that, from a brand, what are other people saying about that brand, right? You want kind of social proof or validation for the decision. And so I think, a lot of what we're doing is helping search under the hood with our AI experiences to reason about those kinds of questions and help give you these overviews with links for you to click in and to learn about these things so you can make a call. That might be like, actually, for me, 95% of the journey.
Hmm.
And then, of course, at the last step, if you gave me like one of those one button autofill things and it wasn't even in the product and I said buy, I would feel like you kind of nailed it. And so versus if you invert it and it's like, well, I could buy the thing for you, but I'm not going to help you really crush it on the first part of that kind of thing, you'd feel like you're really letting me down. And so we kind of, in what we've done with agentic and something like our dining experiences and our booking, you can go into AI mode now and say, hey, help me find a table. What's a good high rated burger spot for SF for date night for 2 people? And it goes and figures out all of the best places and what's notable, what are people saying, constructs this experience, but then it'll also bring back talk and open table availabilities for each of these things. Now it doesn't book it for you yet, but like that, I would argue is like so much of the need. That's where we've started this whole thing, and we've expanded now to local services, haircuts, etc. But I think that of course the next step is there an easy way to get a quick preview and just complete the action if it's easy enough, and then it's possible over longer periods of time, you have these agents even in the background like looking out for you in various ways, pinging you opportunities it's finding, etc. And I think that's very exciting too. But I think further out, given just people's needs today.
So I'm really curious about, and changing gears just a little bit, but curious about how Google is ranking AI generated content, how it interacts with AI generated content. Is it favoring content that it views as human created? Do the SEO best practices hold up when you're trying to show up in an AI overview? Walk us through like that whole thing. There's a
Yeah.
lot there, I know.
Well, what's interesting is the way it works under the hood, like the core mechanic of our AI system, is a model takes your question and reasons about it, tries to understand what are you trying to get out of this, and then it actually will generate a fan out of like potentially dozens of queries. And actually Gemini 3, there are even more queries and more nuanced questions that are being kind of effectively Googled under the hood. And then by doing that, it's kind of the approximating, what are the pieces of information, websites, resources that people have found helpful for these given questions. And so there's this very strong association to the quality. Like I said, it's like 25 years of quality work and learning around, hey, there's a piece of content, it's about this topic. Has someone found this helpful for the given question that they are asking? I think Google's unique opportunity here is that those connections are more clear. And so you can kind of like say, here are the things you should know about the question. Here's a bunch of links, right, that are relevant for the questions you've asked. In many cases, they're actually questions you didn't personally ask, but they're like fan out questions under the hood. So it creates this like greater diversity of content and information that comes back than a traditional Google search, because it's going deeper and doing all this analysis, like kind of this research for you under the hood. And then it comes back. So it's kind of a long answer, but the short of it is the same things apply. So is your content directly answering the user's question? If so, the user is more likely to value it. Is page quality, does it load quickly? Does someone value it? You think about something like originality. You think about something like, does it have sources in it? Does it cite information? Like, what are the best practices of just having high quality, trusted information? And then for people, are they clicking on it and valuing it and coming back to it? That stuff is going to rank for a given question, and it'll also rank for a question in the AI world. And that's what we're seeing. And now I think what's different is people use AI for different things. It's all similar things, but the weight of them are different. Like they're using it a lot for things like advice. Help me figure out my finances. Help me figure out what to do about school, or help me figure out this relationship issue. So you're going to see a different mix of what people are trying to get. And so people and creators in those spaces are likely to benefit, I think, in understanding that dynamic, and creating helpful content for those needs.
And Robbie, we've been talking a lot about the changing nature of search, and AI powered search relative to kind of the traditional Google search is still, expensive. And so for me, I pay for a lot of AI services. I'm more than willing. I'm very happy to do so. But then how are you thinking about the search experience for potentially the different segments of the audience who are doing Google searches that might have different tiers? So the free tier, the pro tier, the ultra tier, is the search experience going to change? Is it different today based on the tier that somebody might be subscribed to?
I mean, our principle overall is that everyone should be able to tap into information and get information about anything on their mind. And we will get the best possible, most efficient model for you to do the work, given the question. Now, I think what it means is, as a baseline, is that should be a baseline expectation. And so if you, and we're starting to do this today, we have model routing already in the system. And so if you ask a pretty simple question, you may not need a really powerful model. The other reason why is powerful models take more time. It's a latency question as well. People have an expectation it's delivered really quickly. But if you ask a question that's about, how much money do I have in my retirement account after 15 years if I've maxed out my contribution every year over the last 15? Kind of interesting, right? You have to like look up what was the max contribution over 15 years and what was the market return for an 80-20 portfolio or something. And then you have to add all, it's actually like a fair amount of reasoning.
Mhm.
And the user may expect it to take some time. That'll tap into a more powerful model, as an example. So that's a base case. And we think we've been able to achieve that at scale already. And what happens is over time, the most frontier models, they end up kind of being brought out to more and more people over time, in the same way that you had Gemini 2.5 Pro, you had 2.5 Flash, right? And you had faster models that had the core capabilities retained, but they were smaller, faster, et cetera. And so right now we've done that with, if you think about AI overviews, has 2 billion users that use it. So we have AI at that level of scale. But the difference is, I think, if you're a paying subscriber, like, you're going to be able to probably have higher limits and tap into more of the reasoning, thinking, and really more advanced AI tools that are going to be more intensive. And that's why we're starting right now with, the frontier model, which does take more time with Gemini 3 Pro in search for paying subscribers. And then hopefully over time, those capabilities become easier and easier to bring to more people.
That's super helpful to know. And just to clarify, Google search is using multiple flavors of the Gemini family of models to serve kind of the right amount of inference, the right amount of test time compute at the right time.
Yes.
And can you just talk a little bit about like how that works, how the routing actually might work,
Yeah, I mean, if
without
you're
getting
going
into
into
too
Google
many
right now,
details,
I mean,
obviously.
like if you go into Google, we want you to be able to put anything you want right in the Google search box. Like right now, if you want to go type in how I get ketchup out of my stain out of my jeans, put in Google, you get an AI thing. But if you also put in a pretty hard math question or coding, like those hard or a multimodal question where you have image and you need image understanding and you're asking like, what's this plant and why is this like leaf brownish and how do I fix like, is it like unhealthy? It's like it's going to need some power. So those kinds of questions are routed to more powerful models like Gemini 2.5 in order to have the more advanced reasoning and multimodal understanding for those kinds of questions. And that's happening now. And that just happens through kind of like an overtime, a learned understanding of what questions have, you know, jumps in helpfulness depending on the model. And we test these things. Like if you spend too much time thinking and the model doesn't really give you, that better of a response, you're going to kind of lose the user. They're going to bail because they're kind of like, this is, it's taking 30 seconds to give me something that isn't that much better than the one that was fast. So it's complex how the system actually works, but that's the principle behind it.
Makes a lot, excuse me, makes a lot of sense. Maybe two final questions here. The first is, and you touched on this a little bit at the beginning, but I wanted to ask you a little bit more directly. What's the simplest distinction between how someone may interact with, ChatGPT or Claude versus AI mode? Like what sets AI mode apart from those systems?
Yeah. AI mode is designed for information and it's for what people use Google for, but from an AI perspective. So it's not designed to be another general purpose chatbot that you talk to. It's designed to help you with shopping, with finding restaurants, with knowing about how to deal with your passport issue and like what have people said and done to get around some issue, right? And those are the reasons. It's for inspiration. So you can go and ask, hey, I'm looking for designing my daughter's bedroom, and it's gonna reply with visual. People love image search. It's a big thing people come to Google for. So those are the use cases, these kind of rich informational things that people really rely on Google for. And it's really about knowledge and it's about getting information. And that really is where we see kind of the most usage and the use cases in AI mode. Whereas, chatbots, I think they have a very broad framing, but a lot of time is on things like productivity. It's on things like essay writing or, code. And we do those things, but that's not like the real focus of what we spend all of our time obsessing about quite in the same way.
And so if people want to have more of a traditional chatbot experience, they're going to Gemini, kind of gemini.google.com. And then if they're trying to get information, they are going to Google search. Do you ever see those two products converging in the future?
I mean, I think we're lucky in that there's a few different, like, yeah, I think the main thing to remember is we're going through a rapid expansion in the market and in the info needs. Like the amount of questions people have is very large, but the amount they could actually ask and get help with technology for was small. And now with AI and the ways that these systems are evolving, you can get help with anything almost, and everyone's going to have a little different flavor. And so I think that, we don't really believe that you should force a user to do any specific thing. If you're someone who's always in the Gemini app and you're using it all the time for coding, for homework, for work, you're running your business on it, you're getting it to generate flyers and images for you, and you ask a one-off question about, informational question, like that's going to use like a Google search tool and be great information, and that's great. But if you're a daily Google user, and by the way, there's a lot of those people, and you want some help figuring out what to buy or like where to eat tonight, AI can be helpful for you. And we think that people have been liking that. And so it kind of skews more like what are people using the actual products for? And then AI becomes these like enhancements for those use cases versus feeling like they're all kind of becoming one product, in my opinion.
Yeah. We were just talking to Bryan, the guest before you, about personalization and how AI is going to become that much more valuable when it's fully integrated into your life and it knows what's going on at a more personal level. Obviously, there are some current concerns about that too, but that's for another day. Google has this rare opportunity that a lot of other companies don't, where it's intimately familiar with, oh, I just bought a flight on Google's site. I just went shopping, Google Shopping, and has access to my Gmail. Like it can become this incredibly powerful and helpful assistant. With that in mind, you have this launch under your belt. It's in the rear view. Like, what's next? What are you excited about in the next 12 months?
Yeah, that is
Or maybe we
definitely
should say
one.
6 months. 12 months is too long.
6 months. Even 6 months feels like an eternity these days.
Yeah.
But I actually think you hit it right on the head, which was, I think that how these models can be uniquely helpful to you based on your personal context of what you're going through is a really awesome opportunity. And actually at I/O, we announced that we are working on experiments to how our AI models can understand things like Gmail, with your permission. And I think that's a very exciting opportunity for us over time, and for AI to be uniquely helpful for you. Because if you knew like what, recently I was what shoes I was buying, it's really helpful to just get started helping me with the next task. Or same with restaurant, all kinds of every journey we talked about on this talk here, actually. So that's certainly one. I think a related corollary is around how the models personalize their experiences around you as well. I think what's really interesting for this new version of Gemini 3 is it's so expressive that if you're wanting information to be very visual, it could do it. If you want it to be audio, you want to take it away, you want to go for a drive and just like convert that whole thing into a conversation, you can do that now. Like there's a live version of Search you can just talk to on Search Live, and it's just live. It's the same model. It's like the same model and knowledge intelligence that's built, like understanding Google's kind of knowledge base. And you could just go for a drive and just talk to it. And that's pretty incredible. So I think you're going to see this adaptability in how the models interact with people based on their preferences and their own context as well. And that's going to be pretty exciting.
Awesome.
Robbie, really want to say thank you so much and congratulations again on all the incredible launches this week. If you want to check out Robbie on X, RM Stein, and check him out at google.com. Robbie, thank you so much. Come back again.
Thanks so much for having me. Appreciate it.
All right. Yeah, very cool. This was a very fascinating show. Just want to say thank you to everybody watching. Nick, thank you for being a co-host today. I want to thank the guests, Himanshu Tyagi, excuse me, co-founder of Sentient, Misha Laskin, co-founder and CEO of Reflection, Bryan Catanzaro, Vice President of Applied Deep Learning Research at NVIDIA, and Robbie joining us, Vice President of Product for Google Search. And thank you. We're taking off next week for Thanksgiving, but we will see you the following week. Nick, thanks again.
Thanks, everyone.